Okay, descriptive statistics. Now remember the definition of statistics. Statistics are just facts, right? Numerical facts about a population or a sample. A good analogy I like to make is, let's say that you're trying to describe a car. So suppose that somebody come and ask you, say, what kind of car do you drive, right? Now, how would you answer that question? Well, you could say, okay, I drive a truck, right? And then you can say, well, the truck has four doors. It is a Nissan. It is 4-wheel drive. It has leather seats, and so on and so on. Right? You can see that what we're really doing is just naming or describing characteristics about an object, about a physical object that exists in reality. And statistics are just numbers, are just ways, different ways that we can describe this physical thing, right? This object that exists in reality, and that's what really chapter 2 and chapter 3 is it's all about. Is just coming up with a way to describe this object, and in our case, right, the object that we're trying to describe is the sample. You can think of it as the blood pressure medication of a certain population, or it is the opinion. In case of survey data, it is an opinion of a certain sample, right, a certain population, and that's what it really is. All right. So now in chapter 2, we're going to break down we're going to break down the variable into two different categories. So we're going to say one is a categorical variable, okay, and these are just pretty intuitive. There's just if we have a survey data, right? Which we'll give an example, but things are in categories and names, right? Okay, so not numbers. Or quantitative variable. So these are numerical. These are numerical values. Okay. All right. And then so we'll start with categorical data. Okay. And the easiest easiest statistics that we're going to learn first is called the frequency distribution. So frequency distribution is the tabular summary of data showing the number of frequency of observations, right? Okay, and the goal, right, is to provide some insight, right, that we can see from just looking at the raw data. Okay, let's start with an example, and it will become much clearer. Okay, so let's take a look at this survey data here. So here are sample of 20 guests. And by the way, that's a good habit. Every time we see a data set, you just want to write the sample size on the side. So n equals 20. That's the sample size. Okay, and here's the survey data about the quality of their accommodation. And here's the raw data, and from just the looks of it, right? What can we say about the customer's response? Right, and it looks like most of them are above average. Okay, and with the data set this small, right, n equals 20, we can see it pretty easily. But you can imagine if the data set gets bigger, it's going to be much more difficult to make out what is are the customers satisfied or not immediately like this. So the raw data doesn't give us a lot of information. Okay, so let's make a frequency distribution, right, or frequency table. Okay, so first thing we do is here we're going to do. We'll use this spot here. Now, the first thing we do with frequency distribution is we identify all of the categories that's in our survey. So let's use this category here. We'll come down. So what kind of categories do we have? And you can choose to go in order. You can go into ascending or descending order, and sometimes with categorical data there is no order, so it doesn't matter. Now in this case there is a natural order to things. Okay, so feel free, we can do poor on top, okay, and then we do below average, average, right, above average, okay, and excellent. Okay, and that's going to be our rating, our categories. All right, so these are our categories. Okay, and then here is going to be our frequency. Okay, And to get this, it's very simple. You just count. You count off how many poor ratings were there out of the 20. And now we don't divide, so we just count the right number, how many pours are there. Okay, and so a good way to just kind of cross them off, pour. Okay, 2. Okay, and then just go ahead and cross them out and then go ahead and give it a count. Right? There's 3 there. Average, I'm going to go a little quicker. Feel free to pause if you want to count them on yourself. The average is going to be 5. Above average will be 9. I counted this earlier. Excellent will be 1. Okay, give it a count. Check your answer here, and that's it. That is the frequency distribution. Right? Okay, and now with this all counted, right, what's the advantage here? Right, a couple things we can see is that 9 out of 20 reported above average. Right, so now we can get it very quickly, right? And a lot of it is sense about the ease of accessing this information. We can get a sense of there's a lot of people is right, is satisfied. By the way, if you count this right, when you add down, it should equal 20, right? When you add it all up together. Okay. All right. Now, this gives us the absolute numbers, the frequency, but it doesn't tell us the proportion. All right. And sometimes that's helpful. All right. So let's go with the next one. So relative frequency distribution give us the proportion of the response, right? That is in that category. Okay, so here we have the table here, and typically the way you want to do this is just to add another column next to the frequency table. So we're going to add another column here. Right? Relative frequency distribution, and now the way we calculate is simply you take the frequency divided by the sample size. Okay, so this one is going to be 0.10. How do we get that? Right. So for pour equals 2 divided by 20, so equals 0.10. Okay. All right, so that goes there. All right, and then just 3 divided by 20, 5 divided by 20, and so on. Okay, so go ahead and do the calculation. Pause the video if you want to try it on your own. Okay. All right. Now, we can interpret this information a little bit differently now. Here, with the frequency distribution, we can say, well, 9 out of 20 says above average. Okay. This gives us tells us a similar information, but in a different way. This says, 45 or 0.45 of the proportion of the responses considered a accommodation above average. Right? So we can make different statements depending on which distribution we use. Right? Okay. And by the way, if you did this right, if you add it all the way down, right, then you should get 1. Okay. When you add up the sum of the relative frequency, we should always get a total. You should always get a total of 1. Okay. And now, what if I only have the relative frequency? So let's take this for example. Right. This here, I know that the average response 0.25. Right, 0.25 respond to average. But what if I want to know how many is that? How many people actually respond average? So all I have to do is take 0.25 multiplied by the sample size. In this case is 20. Right? If I take 0.25 times 20, right, then I'll get 5. So I can get back my frequency as long as I have the sample size. So here's relative frequency times by n equals frequency. Okay, it's a nice handy formula. So when we say proportion, let me go back to the page here. When we say proportion, we always say 0.15. Right, proportion is 0.15, proportion is 0.25, and so on. So relative frequency is always described in proportion. However, in most everyday language, most people are more used to talking in terms of percentage. So then therefore, right, let's do a percent frequency distribution. And all percent frequency distribution is the relative frequency multiplied by 100. So here we have the frequency. Let's go ahead and extend this table to relative frequency. Again, relative frequency, the same calculation. Okay. I'm going to just copy down the number I had before. Okay, now to get percent frequency, just multiply by 100. Percent frequency distribution, so this would be 10, 15, and so on. Okay, if you add up the total for both of these, right, relative frequency, remember, it should add up to 1. Percent frequency, well, if I have all of the category and all of the responses, it should add up to 100. Right, 100%. You don't have to write the percent sign here because this column is already assumed to be in terms of percentage. Right? And I can make different statements now. Right? I can, nothing conceptually, nothing is conceptually, right? It's not difficult here. I'm just moving some decimals around. Right? And so, for example, with relative frequency, I can make the statement saying something like 0.15 proportion. Right? Proportion is below, right? Is a below average. Okay. Again, in everyday use, most people, we don't talk like that. We don't talk this way. We don't say we don't use the word proportion that much. So instead, we can say, well, 15%, right, of rating is below average. Right? That sounds a little bit more natural. That's all it is, right? Okay. All right. So let's give this practice problem a try. So we have A, B, C, 3 responses, okay, and then here it gives you the sample, like the survey response, okay, and let's construct a frequency and a relative frequency distribution. Okay, go ahead and pause the video if you want to give this a try, and you can check your answer. Check your answer after you're done. Okay, draw the line. Okay. First, write down the categories. In this case, I'm going to call them class. Okay, you can call them class, ratings, categories, doesn't matter. You can use a lot of different words for this. Right? Okay. And again, if things have a natural order to it, then go ahead and put it in that order. But sometimes with categorical data, there is no natural order, so you do not need to put it in order. Okay. Here, since this is ABC, I'm going to need to put an ABC here. All right. First, you always just need the frequency. Okay, that's already counted for us. Oh, I didn't use my own advice. You should always write down what the sample size is. So the sample size is 120. So here, n equals 120. So write that down. Okay, frequency A 60. There we go. B 24, C 36. Okay, next column. Let's go ahead and make the relative frequency. All right, and the relative frequency 60 divided by 120 equals 0.5. There you go. There you go. And if we add all this up, this should equal 1. If you add all this up, this should definitely equal 120. Okay, this will always equal the sample size. This will always equal 1. All right. Okay. Practice problem number 2. Okay, go ahead and pause the video if you want to give this a try. Okay, all right. So here I have part of the information missing. What is the relative frequency of class D? Okay. So to figure that out, right, what I would need to do is knowing the fact that if I add all this up, this will definitely equal 1. Therefore, I simply take 1 minus the sum of the rest of the frequencies. Okay, this total here equals 0.8, so the relative frequency will be 0.2. Okay, next, if I know the total sample size, what is the frequency of class D? All right, well, class D, so remember to get from relative frequency to frequency, you just take 0.2, that's the relative frequency, times the sample size, 200, right? Then that will give me 40. Right. Next, show the frequency distribution and the percent frequency distribution. Okay, so let's go ahead and utilize this table set, this blank spot here. I'm going to call it class. Okay, here it's got a natural order to it, A, B, C, D. Okay, so frequency. Okay, I'm going to follow the same formula. You take the relative frequency multiplied by the sample size. Okay, so we have the relative frequency up on top here. Okay, if you did that, so try it. Pause if you want to try it on your own first. If you did it correctly, this is what you'll get. Okay, that's the frequency. Now I want the percent frequency distribution. Right, in other words, I want to know, right, like for each of the class, what percentage is the class, right? What percent of the response or what percent of the proportion is the class. Right. And so to get this, you simply take relative frequency and then multiply by 100. All right. If you did it correctly, frequency, if you add it down, you should get the sample size. Percent frequency, if you add it all the way down, you should get 100. If you did that correctly. So just a quick recap here. Right? Quick recap here. A, to get the relative frequency, right, you're using the fact that all of the relative frequency added together have to equal 1. Therefore, you take 1 minus all the other relative frequency, it gives you the remainder. That will be 0.20 right there. Okay. Second, I have the relative frequency. How do I get the frequency? We can use this formula. Frequency equals relative frequency times the sample size. And there we go, we got that. All right, and the next, then just filling in the constructed table. Now there are typically 3 different ways we can use to describe any data set or any distribution. So one is the tabular form, which is what we have here, and another one is with a number. Okay, so just give a number. We'll talk more about that a little bit later. And another way to describe the same thing, to describe the same object, is with a graph, a graphical display. Okay, and they're all considered statistics, right? Because remember, statistics is just facts or characteristics about a population or a sample. Okay, now there are infinite different types of graphical displays you can depict any kind of data, right? And the one that we're really going to focus on and just practice how to draw is a bar chart, because a bar chart is something that we will be using a little bit later on into the semester. Okay, so a bar chart Right, on one axis, we're always going to do the horizontal. Always going to do the bar starting from the horizontal axis. Okay, and we can use a bar chart could be used to describe the frequency, relative frequency, or the percent frequency. Okay, so for now, let's do it for frequency. Okay, so all right. So here on the bottom, I'm going to draw a horizontal axis and where I'm going to write the labels for the class, right, for each of the class. Okay. So here I have poor, okay, okay, and below average, I'm going to use shorthand here. Okay. Average, above average, and excellent. Excellent. And always label your axes. So here is my class. Okay. And then next, I'm going to have a vertical axis. And now I want to do a frequency distribution. Okay, so here is my frequency. Again, you should always label your axes. Okay. And so poor, I have frequency. So here, I'm going to look at my frequency. And let's just look at my highest number is 9. Okay, so I'm going to just take the liberty, and obviously it'll look better if you do it on graph paper, but this is good enough for us to get the idea. Here, I'm just going to do the best I can to make equal distant markers. 1, 2, 3, 4, 6, 7, 8, 9, 10. All right. Okay, so poor 2. Okay, the poor is 2 here. There. Okay. Below average is 3. 1, 2, 3. Okay. Average, right? Average is 5. 1, 2, 3, 4, 5. Now, before I continue, right, a couple things, and these are just good norms, right, to follow. Right? They're not rigorous rules. There's no authority figure that tells you what to do these, but these are just kind of standard practice, right? Which I kind of missed already. One, right? These are categories of rating. Okay, so there's no reason, right? No reason why these width should be different. And so these really width, right? You should do the best you can to make these width the same. Okay. Second, because this is qualitative data, meaning quality, right? Qualitative data is not continuous. There is nothing between poor and below average. Okay, they're completely separate ratings. They're completely separate class. Therefore, the standard practice is you want to leave a gap between the classes because it is a qualitative data, right? They are ratings. Okay, so one, make the boxes the same width, and two, put base spaces between them because they are not continuous, right? There is nothing between them. Okay, so let's continue. Above average, there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Oops. Okay, and then for excellent, there's only 1. Okay. Now I hope you can see that with the bar chart, right, visually, it's the same information as the frequency distribution, and yet visually, right, I can get a sense of right away which has a higher, which class dominates the response, which dominates the rating. Right? And here we can do maybe a trend line. Right? And we can see, right, you can see the distribution. Okay, a little bit clearer here.